The next speaker is a ILP, representing an ILP member company called Gore. Matt Decker is the technical leader in the Comfort and Biophysics group. I didn't know that industry had comfort groups. This is very, very interesting. And he's going to talk about smart fabrics and a lot of other interesting things that they are doing along the line of comfort science. So Matt, stage is yours.
Thank you. Well, first, thank you very much for the opportunity to speak today. I'm going to give you a brief introduction. So my name's Matt Decker. I've been with Gore about 11 years. I currently lead our Comfort and Biophysics group, and I'll talk a little bit about what that means today. But first, I'll tell you why I'm here. So you get me today because at Gore, we're doing some digital health stuff, but we're not quite ready to talk about that yet. So instead, we're going to talk about some of our comfort work. And what I want to introduce today is quite a bit different from anything that you've seen before today. Right? So today's all been about really new, exciting things. What I want to introduce is the challenge of being a big company that's really old. Right? We've been selling Gore-Tex for 40 years. And so I want to introduce a problem that we've been working on to try to improve our user experience and to really improve the way that people perceive comfort in Gore-Tex. However, we ran up against a technological challenge, that I think a number of people in this room would probably be helpful in solving for us. So I want to introduce the problem to you, talk through where we got to, and what I think this ecosystem could look like with a technological solution that's just beyond the scope of skill and that we have at Gore. So my talk today is really about integrating sensors, AI, and comfort science. I'm going to try to limit the buzzwords to create an ecosystem that really talk about how we get dressed. So I'll start with Gore because we've got to tell a little history to make this sense. So for those of you that don't know, Gore Associates was started in Newark, Delaware by Bill and Vive Gore. So that's them there. And like any good startup, it started in their basement. And there's a picture of their house there in 1958. We're still a private company, and we're still one of the largest private companies in the world. We do about $3 billion in sales, and we're about 10,000 people. But as I said, that means that we have a lot of the challenges of being a big company. There's a lot of inertia. There's a lot of challenge and change. And in my particular example today, we have a Gore-Tex brand that's worth probably about $1 billion. So that means you have a lot of risk associated with doing anything that might compromise that brand. So we're trying to do things outside of our core business to engage our consumers in a different way and to get people excited about Gore-Tex again. So that's what my talk is about today. So again, Gore Associates, most people know us for Gore-Tex. That's our waterproof, breathable materials. We launched it in the 1970s, really changed the way outdoor gear was worn. We also were in almost every set of firefighting gear that's worn, and we're in a lot of Gore-Tex shoes. But we also have a very large medical products division, really based on bio-compatible implantable medical devices to solve life-critical needs. And we have a big electronics products division, which really was the heart of the company. And so if you look at those three things, you've got electronics, you've got human biology and medical science, and you've got fabrics. So you'd think those three things together would really be a great platform, or you could bring together a lot of great technology, but we don't do that. And you know why? It's because those three divisions have really developed disciplines and competencies that aren't compatible. So what we know about medical products is really related to implantable medical devices and doesn't have a lot of applicability to our fabrics business. And electronics business is really about high signal attenuation, which doesn't have a lot of integration or a lot of synergy with our fabrics business. So even though we've got a lot of technology and really smart people, we actually have a hard time working together internally. And so I would argue that in fabrics, if we want to create smart textiles and better digital products, we'd actually be better served coming up in front of this audience and asking for you guys to look at our solutions than we would actually be solving that internally. So a little bit about comfort. So I'm the comfort scientist, and really what we're charged with in Gore, or at least in fabrics, is to understand, measure, and predict comfort. Comfort's kind of a touchy-feely thing, so a lot of our job is about quantifying that. And so that really comes down to three things to me. We are ultimately a material science company. We develop unique and advanced materials to improve lives. So that's what we do and what we sell. But to do that and to make sure that our products make a difference, we have to understand how those materials get incorporated into garments, and we ultimately have to understand how those garments are used and how it impacts the end user physiology. And so that's why we do have physiologists in the group, we have clothing scientists in the group, and the rest of us are chemical engineers or physicists. So collectively in the world, we're not the best physiologists by far, right? A lot of better universities that do better physiology work. There's a lot of people doing better clothing science work. But there's no other group in the world that can understand when we make changes at the material level, how that ultimately impacts the physiology and the end user perception. So we integrate that knowledge in a way that nobody else does. This is all background. So here's my question. So every morning, my wife asks me, ask Siri, what's the weather going to be today? Who did that this morning? Anybody? Right, so why do you do that? So you know what to wear, right? So really, we ask what the weather is going to be as a proxy for what should I wear today. And we do that because we have over years and years of experience, and we've built up heuristics, and we've really built up judgments within our own mind about what clothing to wear for a given environmental temperature and a given activity. To give you an example, so I'm a runner, run marathons. I know that if it's below 40 degrees outside, I'm going to wear pants. If it's above 40 degrees, I'm going to wear shorts. Sometimes that breaks down though. And 35 years of decision-making science has taught us that we use heuristics to simplify our decision-making processes, but a lot of times that leads to some mistakes, and in some cases, fatal errors. So my challenge was, we have all this comfort science. What if instead of asking what the weather is, what if we ask Siri what we really want to know, which is, what should I wear today? So have you ever done that? Has anybody ever asked Siri what to wear today? So I was playing with it last night, and I was going to do a demo, but I confused her. So what she actually, her answer is, tomorrow's temperature will be 66 degrees. She tells you the temperature, because that's what we've been trained to do. So again, my challenge was, what if you asked her what you really cared about and she could provide an answer? How would you do that? And there's some good reasons to do that for Gore. So you can imagine that we want to improve our consumer engagement. If we actually had an app and we were able to take all the knowledge that we have with ourselves and our brand partners and put that together, that would be a new way for us to sell more gear, because we could create virtual closets. We could actually tell people, we could potentially improve their performance. So I started thinking about, how would you actually recommend clothing and how close are we? And would anyone care? So we'll start with the would anyone care question, because ultimately we need to make money. And so I thought about what the end user interests are. And so why would I, as someone who's dressing my daughter or someone who's going to go run a marathon, why would I care and value that? Well, I start with the assumptions around, it's going to improve my health, wellness, mindfulness, focus, or comfort. And a lot of, like today, everyone's pretty comfortable here today, right? No one's probably sweating. No one's probably too cold. Maybe a few people are too cold because it's a little chilly in here. But by and large, when you're comfortable, you don't notice it. The study of comfort is really about the absence of discomfort. So double negative. So what this is about from an end user perspective is, it's about being able to do your job better, staying more focused, being happier. If you're an athlete, potentially if you wear the right clothing, you're actually more effective in your performance, or you're able to improve your fitness. Similar to what the other talks were about this morning. So then I think about the current state of wearables and sensors, and heart rate was the first one, right? We've had heart rate monitors for 15 or 20 years now that are pretty good. But in the last 5 years, sensors have come a long way. We can do a lot with temperature, sweat rates, and whatnot, but it's still limited feedback. So at the end of my run, maybe I get my core temperature, my skin temperature, my heart rate, but it's hard to make any instantaneous decisions, right? So I'm calling that sensors 1.0, for lack of a better term. But again, what are we missing by that? We're not getting any feedback on how to optimize our clothing, how to optimize our nutrition, potentially how to optimize our training for a given activity or environment, because we're not predicting any of that, right? We're just simply measuring. There's no feedback. But the first step is certainly to control something, you have to measure it. But we're not yet using that data in a way that's smart. So what is comfort science? Comfort science to me is fundamentally about 3 Ps. So marketing has the 4 Ps. We have 3 Ps. There's physics, physiology, and perception. Perception is really comfort. Perception occurs in the brain. Physiology is the body's physiological response. These are things like sweat rate, skin temperature rise, vasoconstriction, vasodilation, your body's natural responses. Physics is what I care about, right? The material science, what I engineer, I'm changing the physics of the materials that go into those garments. I'm changing the way the garments are constructed, how they fit, how they drape, how that impacts my performance. And then all the other environmental aspects of physics, things like that affect the heat and mass transfer, really, right? So I'm a chemical engineer. I never thought I would do comfort. But fundamentally, really, clothing is just a set of boundary conditions for heat and mass transfer. And your body becomes the heat and mass sink, or source. So our job is to predict comfort and performance. And what we've actually done is we've reduced all of this knowledge to a series of equations. It's fundamentally heat and mass transfer, and sorry, I apologize for that slide. And then there's some external work that actually has modeled the thermoregulatory system extremely accurately. So we can predict the physiological responses with extreme precision. And that's been validated across a range of environments and a range of applications, everywhere from marathon running to sitting in your car in different air conditioning conditions. So we've got all this science. I thought, all right, we're making a pretty good step. And at Gore, we really care about decisions that make an impact at the human level, right? So we're studying the physics at the material level, the laminate level, but we care about the user. And so that's where all of this is designed, right? It's how do you improve that performance and make a significant impact at the user level. So getting to my ecosystem, this is what I'd sort of envisioned, and now we're going to get to where our problem statement comes in. So I've got my user, and she has her iPhone, right? Because everybody, that really becomes your central hub now. So you can imagine you've got an app or a series of apps on your iPhone that are receiving and sending data. Because she's carrying that with her to run anyway, right? She's getting her music and all her integrated fitnesses on that phone. So then we've got sensors. This is that's Spire's sensor. So not a pretty uninvasive. The sensor technology has come a really long way, but you got to get it somewhere. So there's really two primary places you're going to put sensors. You're going to put sensors on your subject to get some immediate and instantaneous physiological response, things like heart rate, core temperature, skin temperature, sweat rate. But you're also going to want to put sensors in the clothing because you want to understand how the temperature changes in the clothing, how much sweat's accumulating in the clothing, things of that nature. So you got two areas where your sensors are going. Now we're also taking that sensor data and we're feeding that into our physiological model. And our physiological model is predicting how we should be responding, right? So that you can modify your inputs to that model to basically simulate anyone's anthropometry, and current state of fitness. So you should predict what the average response would be for that person. So now you can start to understand, in that clothing system, in that environment, in that activity, am I performing optimally or suboptimally? And now you can start to try to identify assignable cause for that. The other thing you can do is now, with some machine learning integration, you can actually start to tune that model for the individual. So you can get individualized responses from her. So let's say every 5 minutes you get, what's your perceived exertion? What's your perceived comfort? And so now you start to link these subjective measures to objective measures. And now I have not only an average physiological model, but I have a specifically tuned physiological model for me, or in this case for her. And so now, when I'm suboptimal, I can start to understand, do I need to change my clothing or do I need to change my training? And I can start to individualize and tailor specific garments and specific trainings for this individual. So what's missing there? Well, one thing is missing is the sensors. We're not fully there yet. The other thing that's missing is I don't know anything about machine learning. I know it exists, I know something about it, but I couldn't do that myself. So this is where we started to break down. So here's the technology gaps, right? We're really missing a lot of the sensors around physiology and use context, and we got some really specific constraints to design around. So we understand the boundary conditions of this system, but we're not so totally certain how to build it. And so what's the win-win, right? Because ultimately everybody's got to win here, because this is now a really fairly complex ecosystem. So the end user, you're getting individualized systems of clothing and physiological model, and ultimately training routines. You're getting opportunities to identify where you can do better, and either potentially actually tell you what pieces of gear you're missing from your system. If you had almost a smart closet, right? So you could tell you if you had this piece of gear from Gore or from Polar Tech or from North Face, you'd be in a much better position to cover a broader range of environments and a broader range of activities. You also get a sense of control and feedback, which is a huge aspect. When you give someone control of a thermostat, even if that thermostat doesn't work, you feel cooler or you feel warmer. You get the same thing here. And the brands would love this, right? Because now you have more consumer insight. You understand how it's being worn, when it's being worn, in what conditions, and you become a lot more relevant. And the technology teams have accesses to teams, partners, and channels, and evaluations capabilities. We've made multi-million-dollar investments that we would be happy to share with people. So in summary, thank you. We're looking for partners to help us do better.